Welcome everyone. I'm Tracy Fitzpatrick and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are thrilled to welcome you to today's event, Developing AI-Powered Applications with LLMs on Google Cloud. Presenting today's topic is Imran Ahmad. Imran is a seasoned technologist and AWS and Google Cloud authorized instructor, specializing in cloud computing, AI, and algorithm design. Known for simplifying complex concepts, he delivers hands-on, impactful training that empowers professionals to build secure, scalable cloud solutions. His writing and teaching bridge theory with real-world application, enhancing skills in cloud architecture, AI, ML, and DevOps. With a multi-cloud approach and a passion for innovation, Imran mentors learners through certifications and practical adoption strategies, making tech education clear, relevant, and career-focused. Please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the Cloud Practice Area. Netcom Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at netcomlearning.com. Today's session empowers IT and business leaders with practical strategies to harness large language models and Google Cloud to build smarter, more efficient applications. As AI adoption accelerates, integrating intelligent features like chatbots, auto summaries, and personalized interactions is becoming a game changer. Learn how to leverage Google Cloud tools like Vertex AI and PLAM2 to boost innovation, streamline workflows, and deliver AI-powered experiences faster and more securely. I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the handouts section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic. Hey, Imran, thank you so much for joining us today.
Welcome everyone. Welcome to this webinar. And today we'll be covering an important topic, we'll be looking into that how you can develop applications, GenAI applications with the LLMs, and we'll be using Google Cloud as the infrastructure. Now, as we know that large language models, they are become sort of a buzzword these days, but they can also be used for some large scale, to solve some large scale important problems. Looking into different verticals, you can use those large language models for software development, for enterprise, for manufacturing, for financial domains. And we'll be focusing on some use cases, and we'll be looking into that how you can use the power of Google Cloud to get things done. So let's get started. So the agenda that I have is right here. So we'll start with a brief introduction of large language models, that what are these LLMs, and then we'll be looking into some core concepts. And those core concepts are about prompts, about tokens, and about capabilities as well. And we'll also look into that if we have more than one choices, how to choose the right architecture and how to choose the right model. We will also be looking into different options that we have by bringing a model into Google Cloud and integrating it with existing infrastructure. And now different people, different organizations have different requirements. Some people, some organizations, some teams, they are very heavy on coding. They want to get things done with their own hands due to different reasons. Perhaps this is part of their larger ecosystem, or they want to have complete control over how the things are developed. So in that case, they can choose the option of using the power of Vertex AI and writing the code themselves. But Google also offers a low code or no code option. There are tools that if your team is not that efficient in writing code, then you can use these options to develop a complete architecture. So we'll look into this as well. And as I mentioned that focusing on two verticals, we'll also look into some real world use cases. And success story is always engaging. It tells you that how other people have used these tools, these options to create solutions at large scale. And lastly, we'll be looking into some responsible AI. And by responsible AI, what it's mean is that we will look into ethics, bias, and safety. So this is what we'll be doing. Let's get started. So first, very briefly, this is not a course about large language model, but it's a good idea that we just explain that what are these large language models. Now, the large language models are essentially, so when we talk about large language models, these are language models trained at large scale offered to us as a service. They are sort of black box. Around $4, $5, $10 million has gone into training them. Months of efforts, in some cases years of effort. So what I'm trying to say here is that this is offered as a black box, and we have no capacity to retrain it. We can customize its behavior. But if we want to make it part of our workflow, we have to use it as it is. We don't have ownership of that, but we have ownership of the larger architecture. Now, these large language models, as that they are not a silver bullet. They have their strengths and the weakness. And the strength of them is NLP, dealing with the natural language. It means that they can generate human-like language. And this is their strength. Dealing with text is their strength. What is their weakness? Their weakness is, if you say that what is their weakness? Weakness is they cannot do complex maths. When you want to use these models for traditional predictive analytics, where you're trying to predict something, for example, you want them to approve or reject a visa application or a mortgage application, they will struggle doing that. You know, so they have strengths and weaknesses that we will discuss. But if as long as the natural language is concerned, they can do a lot. Code at the end of the day is a natural language as well, because so they can generate the code. Of course, the first the first application usually people do is that developing a chatbot, and they can do classification as well. Not Classification is if we are talking about regressors or the traditional classifiers, they will struggle to do that. This is not their strength. But classification in terms of sentiment analysis, positive or negative sentiments, you have a voicemail and you want to see that which of the messages they are positive and which of them are negative, so that perhaps you want to create a feedback loop, listening to the customers' complaints and making an effort to improve it. So large language model are one of the best tools to do that. But again, as I mentioned, where comes the complex maths, large language models cannot do that. They are not created for it. Don't use them for it. So we have to understand that large language models, very powerful processing engines, but they have their strengths and weaknesses. Example is Palm 2 and GPT-4. Now, if we talk about this, so now examples. So of course there are so many other examples, and Google offers pointers, or they have sort of a portal called Model Garden. So let me show you how it looks like. So for those of you who have used Google machine learning before, you know that once you are on the Google's landing page, then no, this is the Google's landing page. It looks like this. So if you are working on machine learning, usually the first tool that you will use is Vertex AI. So let's look into Vertex AI. Vertex in AI is supposed to be a single window operation. And what it means is that anything that is related to machine learning, Gen AI, artificial intelligence is supposed to be there. It's a single window operation. Everything that Google has brought it here. So once you are in Vertex AI, as I mentioned, that this is the single window operation. Anything related to AI, artificial intelligence, is supposed to be here, and we were talking about different models. I said that Palm 2 and GPT-4 are the options, but they are not the only options. So you can essentially, there's a model garden, this is a refreshing name, model garden. It means that all the pre-trained models, I said about $4, $5, $10 million, months or perhaps years of effort. So black boxes that we cannot touch, but we can use, all those models are here. So the way you will do that is that on the left hand side, these are the use cases for which you can find a model. Example would be that on left hand side, if you're looking for a model, or you can search the model here, they are foundational models, or they are very specialized models that are there, very specialized large language models. So these LLMs that we have, they can be foundational. Now, foundational large language models, they are like broad spectrum antibiotic, like GPT-4 is an example. So it is for all use cases, all verticals. They're not specialized in something, Then we have specialized large language models. So Google offers some very well respected specialized large language model. And let me give you an example here. So if someone is in the medical field, and you want to use large language, if you have tried GPT-4, if you're coming from, because medical field, both mental health and physical health, this is one of the important areas where people have experimented with the large language models with different degrees of success. And now, if someone is there, the problem with the foundational or the generic large language model, those wide spectrum antibiotics that I talked about, is that essentially what happens is that those large language model, they do not understand the names of the diseases, right? They do not understand the medical terminology. They do not understand the terms and not only the language used by by the medical professionals. It's also about the prognosis of the disease. So they have some blind spots. They have some quite a few blind spots, and that makes those foundational models incapable of dealing with the complexities of the problems faced by the medical world. So Google has some well-respected models. So if you look into, for example, Bird Bio is the name, if I remember correctly. Bird, yeah, BioBird or Bird Bio. Uh, yeah, BioGPT. Now, BioGPT, it's a large language model. It is pre-trained on large-scale biomedical literature. This is one of the best model of its type that is available in Google Cloud. And because I mentioned before that these all models, they're offered as a service, as a black box. We can just go ahead and use it, and we are not supposed to be retraining them, or we don't even if we want to do, we don't have a capacity to do that. Yes, we can customize it in certain ways, but we cannot fundamentally change their behavior. So if you want to use this model, it means that because the heavy lifting is already done, if you want to use that, all you need to do is that you need to open the notebook, and you will see that the boilerplate code is written for you. It will create the notebook for you, and the notebook is right there. And all you need to do is that you just run it, and here you go. This is all that is needed. Right. So first of all, for those of you who are new to Google, so Vertex AI is the single window operation I talked about. This is the tool that we use to get anything done about AI, about machine learning. Point one. Point two is that within Vertex AI, there's an asset on left hand side. There are different assets within a tool. And one of the assets, as you can see here, it's Model Garden. So we'll remember this name. It's so refreshing just to hear, especially when you are inside Model Garden. It's a garden of models. You click there, and once you click there, it looks. If for those of you who have some experience with that, it will feel almost like Hugging Face. Hugging Face is the open source version of this, and for those of you who have experience with that, you may have. Let me show you that this is the Google version of Hugging Face. So if you go to, for example, Hugging Face. This is one of the most popular sites that we have. If anyone has to deal with the large language model, you want to use it, you want to bring that within your ecosystem. So first thing that comes into mind is that go to Hugging Face. And from there on your top left hand side, you will see that it says model. So you will click the models. And from there, you will search it, or on left hand side, you will find the model that you are looking for. This is the way you will do that here. But Google's version of Hugging Face is this Model Garden. This is where you will bring a pre-trained model into Google Cloud and start using it. The question is that what is the cost, where it's going to run, and who is going to pay for the CPU, who is going to pay the for the GPU, for the memory, for the backend hardware. So this is provision for you. When you will run this, it can provision it for you, but the cost is similar to the one that you pay for an EC2 machine. And roughly, again, roughly, don't quote me on it. You can go to the price calculator and do the calculation yourself. If you want to replace your laptop with a VM that is running in the cloud, so you're looking for around $100 per month. Again, there are so much variation based on your pricing scheme, based on your region, other things there. Just just a rough figure. And if you bring GPU in the picture as well, GPU is needed for a large language model. You are looking at around $200 per month. And then if it becomes out of budget, then we look into need-based use. When you use it, if you use it 2 hours, then all of a sudden cost, of course, it drops to $10 or $20 a month. So it means that the pricing structure will be mostly based on the hardware, the backend hardware that you are utilizing, and that you need to pay anyways. In one way or the other, when you are utilizing the resources on cloud, any cloud, Google Cloud included, someone has to. There's no freelance, someone has to pay for it, so, and that becomes very affordable because it means that it's demand based. If you're not using it, you're not paying for it, so this is basically the way we this is the way we bring the models into the larger Google ecosystem and start using it, Okay, let's move forward and let's look into now. uh, Now let's talk about um, that. Now, first thing is that we are talking about that. What is the business impact of it? Now, business impact is without talking about without talking about that the technical details. Let's zoom out and from the stakeholders point of view, from the senior management point of view, from the people who will allocate money for this project, what is the option, what is the benefit coming out of it, right? How we can quantify the benefit of this effort. So usually we look into three things. Number one, our proposed solution that is more accurate than the alternative, that is accuracy. This is for point number one. So we look into three things. First thing that we look into is the accuracy. How accurate this is as compared to the alternative. So, so the first thing that we look into is the accuracy. The second thing we look into is that whatever solution we are proposing, what is the impact on time? Is it faster than the alternative, right? And at the end of the day, after investing in this technology, what is the impact on cost? So these three are the factors that we look into, that the new solutions we are proposing, is it more accurate? Is it faster? Is it going to provide a better quality of service in terms of time? And then if we can justify this investment because it will lower down the cost, So these three things that we have: time, cost, and accuracy. We keep an eye there. So what we do is that we keep an eye that as we are moving progress, as we are making progress, so what is the impact on these three dimensions? So, so these dimensions that we have, they need to be in green, at least two of them, 1, 2, and 3. Right? So now, now you can say that how we are going to measure it. So we'll talk about this as well, that what is your measuring criteria? Can you justify that whatever you're proposing, if this is a better version of your older system, so these three dimensions, accuracy, time, and cost, will justify this architecture and this whole decision to move towards large language model based architectures. Now, I talked already about Model Garden. I also talked about Vertex AI. Let's look into some other things that come with it. Now, first thing is I talked about Vertex AI. Vertex AI is the single window operation, and I showed you there as well that you go to the landing page, and from the landing page, so once you are in the landing page, so if just like Vertex AI will get you there. Vertex AI, it used to be called AI platform, Google AI platform, GAIP 3-4 years ago. Now what they have done is that they have renamed, they have streamlined the whole thing, and now it's a much better experience. You just go to Vertex AI and hopefully what you are looking for would be there. And once you are on Vertex AI, you will see that on left hand side, you will see there are different tools that that you can see here. So these tools that you have, or these assets as we call them, so these assets will be the one that will help you discover these essentially these different options that you have. So if you strictly look into these options, so you will see that among these options, one of them is Model Garden. Model Garden is what I already talked about, that Google's version of Hugging Face. These are pre-trained models, took large scale models, typically millions of dollars and years of effort. But if you want to develop your own solution, then we have Studio there as well. So on left hand side, you will see a tab that says Vertex AI Studio. Now, Vertex AI Studio is the one that you would use if you want to create a solution, your own solution. Now we'll talk about what that own solution would look like and what that can be. But Vertex AI Studio, this is when you are in dev, you are trying to develop a solution. And if you move above, Model Garden is where you will show, this is window shopping, you click Model Garden and then you see that which model you are looking for. And this is how it will work. If you go back here, so let's write this here. So Vertex AI, what is Vertex AI? Vertex AI, as I mentioned, this is the unified ML platform. This is the, again, I mentioned this is the single window operation. This is where you will go for, this is the shopping mall. Let's say that you want to buy a computer, and in some cities, there are some technical tech centers, the huge shopping mall, that once you enter that shopping mall, that IT center, that whole building, about 100, 200 shops, all of them sells different types of computers, cell phones, repair, or all the services. They also develop code. So this is that building, this is the shopping mall that you have. Now within that, if you want to develop something, this is one of the shops. One of the shops is about Gen AI Studio, and this is what you will be doing is that you are developing the code here. This is where, so if you think about Gen AI, what you can do prompt tuning, you can do prototyping. All of these options are available in Generative AI Studio. Model Garden, the word here is pre-trained. Pre-trained is the word. It means that pre-trained foundational models and some specialized models as well, and those specialized models, they target a particular vertical, a particular domain. I gave you the example of BioGPT. BioGPT is about medical domain. There used to be BioBird, but because this is an evolving field, so now it has been changed to GPT. For those of you who have who know the algorithmic background, so when you develop a large language model from the algorithm point of view, you can either use GPT-based algorithms or you can use BERT-based algorithms. Bird-based, they are a bit more introvert. They think more and talk less. And GPT, they are more like extroverts. They talk more and think less. So it's a difficult trade-off that which algorithms to use, which class of algorithm to use. And it seems that Google previously chose bird-based algorithm for medical, and after trial and error, it seems that now they have moved towards GPT because this is in the name. Now, when you are choosing in Model Garden, again, this is too much detail if you are not medical and you are not in medical field, but it will help you looking at what are the steps involved when you choose the particular solution. Now, we are also talking about LangChain and prompt flow. Now, LangChain and prompt flow, they are frameworks. LangChain is one of the most popular of one of the most popular way of creating an orchestrated solution. So it means that large language model is important, but for a fully functional system, you need more components. You need a place to store memory. You need a place, for example, you may need database. You may need tools to surf the web. You may need to write custom code for your company that yeah, or things like that. So LangChain chain is essentially it chains them together and chains those disjoint components together in a single framework, and that's why it's called LangChain. Now, LangChain is one of the most important frameworks that is there around us, and what LangChain is not the only one. There are other there as well. Now, the another one is the prompt flow. Now, prompt flow is our development tool set, and it is designed to help developers and data scientists to design, evaluate, debug, and optimize a large language model-based workflow. And now it is sort of developed in a way that is focused on focused on solving the challenge of prompt engineering. Now prompt flow, what it does is that it sort of provides you visual workflows as well. And this is what you can do. It is very simple to use, and this gives you visual orchestration of flows. And so there are flows, there are nodes, there are data binding, there are evaluators. Let me show you that how it looks like. So if you go to prompt flow, there was a Google document there on this. Oh yeah, this one is a good document. So if so now prompt flow, what this does is that it, as I mentioned, that there are flows, there are nodes, there are data binding, evaluators, and what you will be doing is that it will show you the charts that look like this. There's an input, then there's a joke, and then there's an echo, and then there is an output. Now whatever we are writing here, the orchestration that we have developed. Now, what is the example of it? Where we will be using this? So now we'll be using this, for example, let's say that you want to build a AI power system to automatically answer customer service emails about refunds. So you have some sort of online store, people are calling about the refunds, inquiring about the refunds, and you want to automatically answer that, and or about shipping, or and you want to use chat gpt model. So first what you will do is that you will design the prompt flow. You design the flow. So now the flow would be input the customer email, that would be free text. Then there will be a pre-processing node. What that will do is that will issue the refunds. Then there will be a prompt node, and then will be post-processing node. So all of this will be shown something like this, as you can see here. And now it becomes very simple, and uh, you can visually see that what's going on and how things are actually being developed. So this is another tool that we have. So Google Cloud allows you to use both of these tools. That is essentially LangChain, that is the orchestrator, and the prompt flow, that is a visual orchestrator. And that is prompt centric orchestrator, that from prompt to large language model, you can visualize that what is the path of your request flowing from the input and passing on to the large language model. Okay, now we talked about the large language models. So let's talk about some key concepts here. Now, first of all, when I said that large language model is all about um, about processing the natural language, right? This is what it's all about. Now, there are some key definitions there. Now, the key definitions is that first of all, they are tokens. Now, tokens are actually like like ChatGPT. Each unit of word that is processed by the large language model, that is a token. And some words, especially the longer words, they need to be represented by two tokens, right? So this is a token. So when you look at the documentation and they say that the token limit is 10K or 20K or 30K. So this is what they're talking about. Roughly 10K will mean about zero point 0.8. You multiply it 0.8. So it will be the number of words. If token are 1K, so it means that 800 words. That's the roughly the relationship between them. Then the way we are talking. So this is first thing. Tokens. So tokens are the smallest unit of data that is processed by the large language model. So the sentences are divided into words, and words are divided into tokens. In many cases, one word can be represented by one token, but in other cases, it needs to be represented by more than one token. So that is the first thing we have. That is about tokens. Now, the second thing we have is about the prompt engineering. Now, what is prompt engineering? Now, the prompt engineering is you can write a prompt. Yes, all of us we interact with ChatGPT and Gemini and other large language models. But prompt engineering is writing the prompt in a structured way so that we can get a maximum response, the best response out of the large language model, and it has a major impact. It's not minor impact. If you think that large language models are not good enough, first thing that you need to look into is that do you know that how to craft an optimal prompt? What should be the structure of the prompt? Uh, So Google, what they have done is that they have come up with a framework, and let me show you what it looks like. So if I go here, uh, Okay. So if you go to Gemini, Google Gemini. So what Google has provided is that the prompts that you sort of optimize after prompt engineering, you can store them as gem. You know, so if you click here, so you will see that it says that explore gems. So if you have Gemini through Google Cloud, or you can directly go to a browser and go to Gemini. So it's a new thing that has appeared. It's called gems. Now, gems are those prompts that has gone through that extensive prompt engineering, and they are supposed to give you the optimal response. They are some prompts that are already there for you. You can have those prompts, you can create those prompts, and essentially that will give you uh, the best use of the large language model that you're using. So here, if you look into on the top, so these are the prompts that are that have gone through extensive prompt engineering by Google, and this is what they want you to use. So these prompts, so let's look into the prompts that are there. So there's a writing editor, there is productivity planner, there is learning coach, then there is career guide, then there is coding partner. Let's look into coding partner. So what this coding partner do is that if you want to look into that how this prompt looks like, if you go here, so let me click it here first. And while you are looking at this prompt, so you can make a copy of it. You cannot edit the prompt. Of course, it's by Google. You cannot mess up with what is offered to a million people, but you can create a copy. Now this is the copy of the coding partner. Now this is the prompt that is created for you. Now you can see that it is structured. There's a purpose, there's a goal. Let me rename it as Imran coding partner and save it now. Save it like this. And now it says that your has been created, and I can start the chat there. But let me first look into this. Your purpose is to help me with tasks like writing code, fixing code, understanding code. I will share my goals and projects with you, and you will assist me with crafting the code that I need to succeed. This is the purpose. Then comes the goal. What is the goal? And what sort of tell me steps in the code development. Then this is the overall direction. Then this is step by steps that are there, and you can of course customize it, and you can make it better if you want. Now Google thinks that this type of uh, now if I want to use it, let's use it. I will say that write code for use of LangChain in Google Cloud. I don't expect anyone here to understand it, but just to show you that after, instead of now I will write this thing here with prompt engineering, with what Google has proposed, and let's look into the response that we get. Let me close this one. No, where did that go? Okay, yeah, here. So now you will see here that after this, now it is, you will see that the response is quite detailed. Because we have specified the instruction that what needs to be done. You see that the detailed response that we got out of it, just by us, because the prompt engineering has gone into that. If I don't do that, if I just say that what is prompt engineering, what is LangChain on Google Cloud, this is what we wrote before, but there was no prompt engineering here. And you will see that the result is there. It's not that the result is there, but the result is simple. There's no code there. It does not know what you want. Just compare it with the result that you got here. And this is the magic of prompt engineering. Same question and two totally different results. And you can see just by this, again, we can pay more attention here, and it will even get better. This is the response without prompt engineering, and this is the response if we spend some time. First of all, we need to know that how we can maximize. All of a sudden, it becomes much more capable, much more useful tool, and that is why if you want to have, this is the second part of it, that the prompt engineering is crafting effective instructions out of the system that you already have. And this is the simplest way and the most effective way of increasing the capability of your Gen AI system. So large language models and even agentic AI, I'm writing a book these days on agentic AI. And the prompt engineering is very important even for agents. And now why token model matters? And our token is it sets the limits. It tells you that because you bill the amount of processing that is done on the vendor's infrastructure, that is actually coming from the number of units that need to be processed, and the tokens will give you the units, both input and output. There's a term that you may have come across, that the context window. Now, what is a context window? So the context window is actually the number of the number of tokens that that a large language model can receive. Now you can see that this context window, as we are moving towards more and more complex problems, so this context window, it acts as it can act as a limiting factor. So let's say that now the context window in large language model is the maximum number of tokens, which includes words both in the input and output. It's not only about the input. Now, what this matter? Because it limits if the context window is too low, even if the model is great. It limits your options. It limits how much information you can give the model at once. And it limits how much history the model can remember in a single session. So as if you're in a session, if you're chatting about a certain topic, it remembers, but this context window, it limits how much it can remember, and also impacts how you design prompts, workflows, especially for complex applications like let's say a multi-turn dialogue, where you want the large language model to remember the context, that what you are talking about. Now, let's say that you write a prompt. User prompts are usually, even with prompt engineering, they are not huge, unless you choose to attach some supporting documents. Now, let's say that you are chatting with large language model, but there is prior history. You are doing it for the last 1 hour, and there are 10,000 tokens in your previous conversation, and the model output, let's say that with each interaction, on average, model is outputting 1,000 tokens. Now, the thing is that if you have 10,000 tokens in the conversation history, so it all adds up, and that all contributes to the token window. Because in order to generate one response, let's put it there in a diagram, what I'm saying here. So let's say that you are here, and our large language model is here. And what you're doing is that, of course, you're interacting with the large language model to give a request, and here comes the response. The question response is here. And what you are writing is that you are only writing a simple prompt and that has 500 tokens. 500 tokens, right? And the response that comes back, these are say 1000 tokens. We defined the tokens already. I think that should be clear, and I said that roughly 100 words is equals to 120 tokens. Roughly, right? Because some words need to be represented by more than one token. This is the smallest unit. We could keep things simple. This is the digital binary representation of each of the words that how the system represent each word. Now this is the maths that is there, and but what's there is that there is a chat history, and chat history has 1000 tokens. Right? And if you have a book or you have a PDF file that you have attached here, and that also has 10,000 tokens, so all of this adds up. And all of this adds up in the context window, because in order to give you the right response that comes here, so the system needs to, first of all, understand your user prompt. It needs to understand the PDF document that you have uploaded as a reference. It needs to go through the chat history that you have, and it has to generate the output as well. So all of this adds up to the context window, and you need to be aware of it, that especially for large scale application, that what is your context window. Otherwise, you will devise a solution that won't work. So now the race was the race towards 1 million. The as in data science world, we call it as the glass barrier, 1 million token glass barrier. And now that that barrier is now shattered by Gemini and others as well. But 1 million is it's quite a big number. 1 million, to give you an idea that if you do the maths, so it is about the books in a home library. This will be for example, the number. If you do the maths, this is what we're talking about. So it means that now our large language models, they are capable enough to through the input, through the PDF files that you have and the output that is generated in one request and response, they are able to process, contextualize the information coming from home library. It's about 100 books, as we can say. Again, these are rough figures just to give you an idea. So this is, but still it's 100 books. It's not 1 million books. It's not 200. There's a limit there, And if you're using these solutions for enterprise world, and sometimes you need lots of supporting information. That is why we need to go towards other solutions like RAG, because there's a limit there, and not everyone is as generous as Google. It means that the context window may be 0.5 million, it may be 0.2 million, it may be 0.1 million. You have to look at the documentation to see that what is the limitation you need to be aware of. Again, we are talking about going beyond the basics. You will use Google Cloud when you are trying to solve some large scale problems. You are not looking at the capital of France, or you don't want to define machine learning. You are actually solving some large scale problems. And this is when you are solving large scale problems, you need supporting documents, you need context, you need to contextualize that, you need to provide the relevant information, and all of that contributes towards the context window. So we talked about this. So these are terms that tokens, prompt engineering, context window, and then there is temperature as well. Now, what is a temperature? So one of the problems then when we move towards solutions that are here in Google Cloud, the complaint is what is the complaint? You will hear it over and over again. The complaint is about hallucinations. What are the hallucinations? Hallucinations are, it's like that kid who is going through an interview to get admission in a prestigious school, and that kid does not know the answers of all the questions. But that kid nearly, what that kid does is that if that kid does not know the answer, still that kid shows the confidence and just look it like that he has no idea what he is talking about, but he will talk about it with confidence, you know, and sometimes it works, you know, sometimes it actually works. But the thing is that if large language model starts doing that, it's called hallucination. So example would be that let's say that there's a redo. I live in Ottawa. There's a redo canal here that becomes the largest skating rink in the world in winters. You know, so if I ask ChatGPT that what is the history of Rideau Canal, and now let's assume ChatGPT is more than capable of answering this question, but let's assume that it does not know that, but it still gives me facts. You know, so it says that there was a kernel, the name was, I think, by drive, and you know we can say that okay, this kernel basically was responsible for creating the canal. And then I say that how many kids the kernel had back in 1854 perhaps. So now ChatGPT has no idea. It barely knew about the colonel who built the canal. It was for the defense purposes. Those were the days when the relationship between Canada and US were not friendly, and the chances were that US can attack Canada, and the canal was built to protect against that threat. You know, those were those times. I'm talking about 1854 or even before that. So now the Chat GPT, Gemini has no idea about the details of the family of that kernel, but it will make up details. It will say that kernel had 4 kids, and these were their names. Now this is hallucinations. The problem is that we cannot tell that whether it was a fact or it was coming out of algorithmic approximations where it goes in the creative mode and it creates new things. You know, if it cannot find anything in the past, it will create new facts, and that's a problem because it means that there is not an easy way, that fuzziness is the power, the creativity is the power. We cannot limit the power, but at the same time we do not want to change the facts through that creativity. It's a difficult balance to strike. It's a known problem and it's work in progress, but this is where we will talk about controlling that randomness, and the temperature is one of the parameters that you can tune the creativity of a large language model. Temperature is the simplest way of doing that. Top K is another. It has a subtle difference that what it does is that when Gen AI generates text, actually it generates a sequence of tokens. And top K means that so each token is chosen from 10 or 20 possible ones, and the top one with the highest probability, the most appropriate one is chosen. So top K means that let's limit those choices so that randomness can be controlled. So two ways you can do that. You can directly control the temperature, or you can choose the all possible choices for each of the tokens as your language is being created by these large language model solutions. Now, so I think it's time for a break. Let's take a short break and then we will come back. Okay, enjoy your break.
Sure, we are now going to take a 5-minute break, but before we do that, we are going to launch a quick poll that we want to invite you to participate in. Doing so helps us know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register.
Welcome back, everyone. Let's continue from where we left off.
Now let's talk a bit about how you are going to choose the right model on Google Cloud. So I said that in Google Cloud, now there are different model families that are there. So as you can see that now Google is essentially one of the largest player in this space, especially when we talk about large language model, because as you would know that these large language models, they are based on a paper that proposed a mechanism that is called attention. That was in 2017, and that was the paper was created by Googlers, and that is why Google is a pioneer. They have some deep skills in this whole area. Now, if you look into different families that we have, so let's go through the list and see that when to choose which one. Now, Palm 2, that is right here. Now, Palm 2. Now, Palm 2 is a general purpose large language model, and it's used for text generation, but it's great for when you are going to have those conversations. When you have those conversations, Palm 2 is a great choice. So so it's so you will see that it has text-based and then there is chat-based. But I talked about the situation where many companies, when they are moving to the when they're experimenting with large language models, the first thing that they do is that they create some sort of chat bot, and this is where Palm 2 comes into play. Now, the second one is Code. Now, Code is it's because when you are coding, there are some specific requirements of coding, right? Now, this Code, it specializes in code generation, code explanation, and code completion. So Code is for that, you know. Now, the use case is that when you are doing, when you're writing unit test, or you want to understand the code, or you want to debug the code, all is there is covered in Code. Then comes the image gen, right? Now, image gen is when you want to create high quality image generation from the text description. Right? It's in the name, so it's not too difficult to look into this. Now comes the Gemini, and you will see that the Gemini is the famous one. This is the multi-model. We use the word multi-model when a model can completely understand the information coming from more than one types of data, video, text, audio as well, you know, and video if it can do that. All types of unstructured data, it regardless of that, it can mesh this up and can extract the signal out of it in an effective way. It's not an easy thing to do because under the hood, the processing requirements of all different types of data, they are very different. They are at very different levels. But if our solution, if our model is able to do that, it's called multi-model. And Gemini is the most powerful multi-model generalist large language model. So we gave you four choices, 1, 2, 3, and 4. Palm 2 for especially if you want to use develop a chat bot. So it will be a simpler but a better solution. You know, it will be cheaper as well because the processing requirements are limited. Code is that if you want to do coding, it will be better for debugging, better for document generation. ImageGen is for generation of the images, and Gemini is the multi-model, perhaps the most famous large language model that is that Google has to offer. Now, how you're going to select which one to choose? Now, for selection, there are different things that are there. So now you can, first of all, do you want to use text only versus code versus multimodal? So these are the three factors that will go into your decision. So do you want only your use cases only about generation of text, or you want to generate some diagrams, some sequence diagrams as well? You want to understand, you want model to understand that as well. In that case, we are pointing towards Gemini. Then are you writing the code? You know, you can see the choices based on the use cases. Then there is cost versus performance. Sometimes you are doing something very simple and you're using something very complex. You know, under design is a problem, over design is a problem. And the model being mapped to your exact needs is needed as well. And then the model size is there, that whether it's a light, standard plus, so all of these. So you need to understand the requirements and need to map it to the options. Four options that I had talked about are here. Now, if you look into different types of services that are there. So Google offers services at different levels. They are managed services. It means that Google manages the infrastructure. So the solutions that you create, they can be one of the types of managed services. It means that Google manages everything and it provides you a solution. The solution as a service. You know, the best example of it is that if you go to Google NLP, so if you go to Google. Now Google NLP, if you click there, now this is a model that is already trained for you. And if you write something here, let's say that I've written this, you want to analyze this, it will analyze you, it will analyze this for you, and it will do entity recognition, it can do sentiment analysis, it can do moderation, it can do categorization, topic modeling. So all of this is done. It's a managed service for you. You are not responsible for managing the hardware. Now the second thing is the scalability. Now scalability, whenever we are developing solutions that are based on AI. So one thing that is important is that what you need is that you need actually something that has elasticity. Infrastructure, you need elastic infrastructure that can expand and shrink. They need to have two qualities. First of all, based on the needs. The infrastructure can expand, it can provision more resources, or it can shrink where those resources are unprovisioned. So that is one thing, because that will allow you to maximize the money you spent. For those 2 hours, you can have those 100 nodes, but the model training is only happens usually for a short time, once a week, is a good frequency. So for that 1 hour in a week, you have those 100 nodes available. But once you're done with that, your infrastructure shrinks, and it means that you don't have to pay much. So this is one thing. The second thing is that because that will bring scalability. The money that we have, so of course, in every project there is a limited money we have. We spend it to expand, to parallelize our infrastructure when there is heavy lifting that needs to be done. Now, then the third one is the integration. It means that because you're using Google, so you would be, it's very easy. It is very easy to connect with other services like BigQuery, cloud storage, data analytics tools. So it's very easy to do that. It becomes very easy. And the third thing is that the fourth thing, in fact, is about the security and reliability. That is a vertical. It means that all the services that is there, it needs to be secure. It needs to be reliable as well. These are what we call as the non-functional requirements of machine learning. So these ones are the non-functional requirements, because if the solutions that we have, they are not secure, both the data and the compute dimension, they need to be secure. It means that so there are different threats that we have. There's a threat of model poisoning, there's a threat of data poisoning. It means that someone messes up with the data, and when we will train the model from that data, it won't be the right rules, it won't capture the right logic. The model can be poisoned. A hacker can change the rules so that the decision making can be impacted. That depends on that model. There can be someone can steal the data that is there. That's the type of threat. There can be insider threat. A data scientist working as a human, there's one of that can be corrupt. If you start using these solutions for some decision making, then we need to make sure that it's fully protected. So these are different things that we need to worry about as we move towards the finalizing the architecture and making our choice. Now, I talked about this, that Google has a family of foundational models. Now, foundational models are if you have more generic requirements, then foundational models is a good choice. When you want, we call it as wide intelligence. The intelligence that machine learning in general and Gen AI in particular, this is our ability to build the cognitive abilities that human possess into machines. You know, that cognitive sophistication, the ability to think, the ability to solve problems. Now that is a human attribute, but we are trying to build that into machines. But as we build that into machines, there are different levels of that. And now we divide the AI, that artificial cognitive capability that we try to build in machines, the artificial problem solving skills, at two levels. There is narrow and then there is wide. Narrow AI is that your solution can solve only one problem. Your solution can approve or reject visa applications or mortgage applications, or can differentiate between cats or a dog. This is all it can do. This is one thing. The second level is wide. Now we can solve more than one types of problems. We are capable of doing that. Lots of problems. Let's say that I'm now conducting this webinar, all of a sudden there's a glitch, so if, the screen is gone, the power is off, and you guys are disconnected. Now it's a problem, I may not have seen exactly the same problem before, but my wisdom is expected, my intelligence is expected to at least make an effort to solve it. If there's a power shutdown, and or if there is network breakdown due to things that are beyond my control, then I can try, but I cannot solve. At least I am expected to do something about it. Now the machines, if they have that fundamental capability to solve any problem, that is called wide intelligence. They are not only limited to one type of problems. Any problem thrown at them, they can solve it. Now, the reason I'm talking about this is that these foundational models is our best shot at providing this wide intelligence to the machines. Because I said that foundational models, they are $5, $7, $10 million. Lots of months, in some cases a couple of years of constant training, they get us there. But this is where if you ask ChatGPT something about mental health, it can answer it. If you ask it to code, it can code it. If you ask it to plan a trip for New York, it can do that as well. If you try to look into history, that what was the name of the sister ship of Titanic, it can answer that question. Or if you can say that my microwave is broken, it will try to help you with that. So it means that this is our best. It is not limited to one vertical or one domain. And this is where the foundational model, but sometimes it's an overkill as well. And when you are trying to solve too many problems, or it's capable of solving too many problems, sometimes it cannot go deep enough. And that is why if we go back here, so we said that there is Code. Code can go deeper than Gemini in code. This is where we say that if you look into, I gave you the example of BioGPT. BioGPT is much more capable. Out of those wide intelligence, the dream, the dream solution of that is AGI, as you will, artificial general intelligence. There's an AGI is a term that is used by Elon Musk and others as well. The Bill Gates, and you will talk about AGI is in the news. AGI is the widest, the intelligence that we have. We are not there, but foundational model is a good shot at that. But if you narrow that down to a vertical, now BioBERT or BioGPT, the specialized large language model, it still has wide intelligence, but the width of that is limited by the vertical or the domain it has. It won't be able to suggest you movies but it has the width within its domain. It can talk about diabetes. It can It can talk about mental health. It can talk about the post-operative care after a surgery. So the width is controlled, but it will be deeper than a foundational model. So this is where you need to make a decision that whether you are going ahead with the foundational model, or you can find a specialized large language model that will save you some cost, and it will be better for you. So this is a decision from coming from the requirements and looking at what is available. You may not be able to find a good specialized large language model, a well-tested large language model, because if you're working on a very specialized domain, chances are that there is not that much commercial interest of companies, big companies, to work on that to solve it. So you want, in that case, you will have to use a foundational models. Now, then if you want to look into that, what factors goes into select your model, it's about the use case. Use case is important, that what you guys are working on. This is the first thing, what is you are trying to achieve. Is it about summarization, or it's a multi-turn conversation? Because in multi-turn conversation, when I was talking about the context window, I talked about that the history becomes part of the context window. So when you are doing a chat, let's say you are chatting with your friend on WhatsApp, the chat itself, both the request and the response, that is usually very short. How are you? I'm fine. How is the weather? Weather is great. What are you doing? I'm biking right now. So you can analyze the request and response. That is short, but the context window, it grows. And in order to build a solution, for example, that can give the right information about someone is want to use this solution at IKEA, the furniture store, the Swedish furniture store. So if you want to buy something, let's say that you are buying a table, and you are interacting with their solution. Now that solution, and then you are chatting that, okay, I ordered that last week. It was dark brown. I am looking for a black one. So what is the difference in the price, and is it available in the store or not? And I talked to you about last week, and you said that you will give me 10% discount. And can you apply that discount to this? If the table is available, it's available in the stock, and the color is black. If possible, send me the picture of that table before you finalize this. And I want to pay it through my credit card, 50% through credit card and 50% through PayPal. Now, it's a complex query, in order to get this done. So the chat the bot that you have, it needs to locate the past history. It needs to process it. It needs to contextualize it. And the whole conversation, it will become part of the context window, and it will start. You can almost imagine that which each further conversation, it is growing. It's an expanding bubble, you know. Yeah, it won't burst, but it's expanding. Expanding bubble always burst at some point, but our systems, they are more than capable of handling lots of information. But you need to know that the solution that you have, it now has a different need than the need than you are interacting with chat GPT or Gemini, asking about the world around you or coding or something. In that case, you start fresh. You start with whether I can bike tomorrow or not. It tells you about the weather. Then you switch the topic. You say, okay, can you help me with writing a code for PySpark? It will help you with that. So then in that case, the it's not your request and response are big. They are huge. Maybe Each of them have 10,000 tokens, especially the response. You won't be able to write 10,000 tokens, but your response, but the conversation history is not that important, especially when you're switching topics. So you have to look for the use cases where you want to use it. Now, you may have looked into the reasoning model these days, the research models available in ChatGPT, in Gemini. You can turn on the research mode. If you turn on the research mode, sometimes it takes 5-10 minutes to go back and research on the topic and come back with the results. But you can wait. You are in the research mode. So, but on the other hand, if you are interacting back to the IKEA example, someone is chatting with the IKEA store, looking at the order. That person cannot wait much. So it depends on the requirements that how much you can wait, and based on that you can devise a solution that, again, this we talked about the functional requirements, then there are non-functional requirements. We talked about two of them, security, and anyone who remember the second one, reliability. So this is what we discussed about here, right here. We said that the non-functional requirements, they are security and reliability. And then the performance is another one. This is the third one. I gave you the example that in the research mode, sometimes we can afford 5-10 minutes. The large language model going to different sites, researching on the topic that we are interested in, coming back with a comprehensive list. But on other use cases, the example is that interacting with IKEA, you will lose a client. You cannot offer. You cannot have a delay of even 30 seconds. More than 5 seconds, the client is gone. Now, then comes the quality versus cost. So sometimes you are doing sentiment analysis. Do you really want Gemini or ChatGPT? If this is for example, now the IKEA store, IKEA themselves, they want to look into, analyze the chat that they were having with that customer. They want to see that whether that was positive, coming up with positive emotions, or they were complaining about something. They want to do that. Now you can do that with an open source model. Even there are large language models and there are language models that they are not large. Large is gone. They are simple language models. BERT is there is an implementation of BERT in Python that can do it for free. You not need to pay anything for that. And simple sentiment analysis, it can be very easily done, or even topic modeling, it can be done by those open source language models. So do not over design. Sometimes you don't. You are using ChatGPT and paying so much money for it, and it's not needed. Now the fourth factor would be that what is your size of context window? Now context window, it is all about the ability of the large language model to process tokens. How many tokens it can process in request, combining all the request and response. And some models you will find that they are very useful, but sometimes they have smaller context window. So it means that they are useful, but they're not useful for the use cases that are of interest to you. Then it comes multi-language support. As the applications, they go global, then based on the requirement, some of these large language models, they are multilingual and some of them are not. So you need to look into this, that what are your needs before you choose a large language model. So these are the key consideration that you will have before you finalize a model. Now, let's look into certain use cases. Let's go through certain use cases and see that how these choices are made for certain models. And for that, let's start with the recommendation. Now, the recommendations are, as we know, they are quite important. Netflix and Amazon and any online store, they this is their fundamental, this drives their fundamental business, you know. So when you go to those stores, online stores, so and you don't know what to buy, so those stores will suggest, okay, why don't you buy this? Why don't you buy this book? Because either based on your history, we think that this is you will be interested in on the people of your age or in your age group, or the profile that you have, gender and other things there as well. So we think that you will be interested in this, you know. Now, uh, there are two types of it. One is based on, we call it as collaborative filtering. It means that based on the people who are similar to you. So they will try to, the system will try to profile you, try to see the cluster you based on your gender, based on your age, based on your income category. The more information it can get, the better it can do that. Or the second one is content-based filtering. So content-based filtering is that the item similar to the item you are interested in or you have shown interest in the past. You were looking to buy razor, you know, for shaving, you know, and it will suggest you some shaving creams or aftershave lotion, because it thinks that they are items you are that are similar to what you were looking for, you know. So now for that, now large language models, they can enhance. For years we were using and, different tools to make this, different algorithms to make these recommendations. Now how large language models can enhance that? Large language model can analyze the natural language processing, like the reviews, search queries, feedback, and that unlocks hidden or unstated preferences. You know, what is an example? Example is that let's say that a user leaves a review that I love books with let's say that uh, I like books that talks about reducing weight using natural products, you know. Now the traditional recommenders might ignore that, you know. Now the large language model can understand that that person is not only trying to reduce weight, but that person is actually interested in the natural products, you know. And now it means that this is the area where that person should be focusing on. That person has just started that. In the history it won't show up, and now this is that person has got worried, perhaps went to a doctor. What doctor ask it to change the lifestyle, and that person researched a bit. Now based on this, it can have that intelligence, that the exact need that may not be coming from two types of recommendations that we used to have: collaborative filtering and content-based filtering. This is about understanding the natural language, the comments, and gathering information of that and making it part of recommendations. This is where it can enhance an already solution that you have. So this is one example that is there. Now, if you look into how you can going to implement this, now for that you can now uh, what are embeddings? You know, now, embeddings are the encoding of the language as will be communicated to the large language model. And let me explain that just a bit. So the words that we use, large language model, of course, do not know English. They need to be converted into, they need to be encoded, you know. So embeddings are an effort where we convert these words into conceptual neighborhoods. King, prince, queen, they are in the same neighborhood. They are about royalty, you know. And apple, you know, banana, mangoes, they are in the same neighborhood. You know, this is called embeddings. Now, embeddings are what's there is that embeddings are to convert user data and items into those numeric representations where your words are divided into a vectorized problem space that have those natural conceptual neighborhoods. This is something that is done in large language model, but now when we are looking into recommendation engines, what can be done is that now user profiles like we talked about reviews or searches or favorites, now they can be converted into these vector embeddings using Google's text embedding model. Those Google provides you with the text embedding models, and that can convert right here. It's mentioned here, so it can convert that into. Now, instead of using a generic embeddings, now this customized embeddings based on, now it means that it will have those conceptualized neighborhoods based on the information that is in the reviews that we have. This is not a generalized solution, so this should be much more powerful. And once you have that, then vector search allows you to search through that to create those similarity and dissimilarity. And large language model would be there once the embeddings are created. It can process information, and the feedback loop will make sure that any misclassifications or recommendations. So if you, for example, suggest something that for if you are suggesting a person a watch, a traditional watch, but that person is using Apple Watch, has no interest in traditional watch, so that needs to be corrected. And this is where this feedback loop will refine those recommendations in a way that the recommendations keep improving as we learn more about our customers, their needs, and their behaviors. Now, this is where if you look into the resources that we have for your journey, so Google has a very extensive vertical Vertex AI documentation for different verticals. This is the first point that we have. The second thing that we have is that there is Skill Boost. Skill Boost, if you go there, there are lots of free resources that are available that will help you try these technologies. So there are some labs, there are some learning paths that you will find. The third thing is that there are community and Google community forums, and some of them are quite active, where you can actually participate in discussions and you can engage in a discussion. And sometimes because they are, you can talk to other people that that is more engaging for that can be a part of your learning experience. Then there is GitHub. On GitHub there is code. Working code, some of them is actually maintained by Googlers, so you will see that this is there as well. Then there is a blog. Now this blog is managed, maintained by Google, and any latest products, the frequent updates are there. So I will like you to keep an eye here. Those 5 will create a learning path that will help you learn more and more about this. Now, generative AI, let's talk briefly about this. Generative AI is something where you generate. This is a generative solution. This is the dev part of it, where you are developing something, And now, generative AI is right here. So Gen AI is that if you go on the left-hand side here, you will see that there's an agent builder. This is the Vertex AI Studio. If you want to create a prompt, for example, here what I say is that help me create a plan for my trip to Toronto. Now, on right hand side, you will see that there are you can choose the model. The models that we have, these are the models that are right there. Gemini, that is the general purpose models that you can use, Then there are third-party models. So if you want to use other models that are available as well, and very well Claude 4, very well respected model that is there. So that is there as well. Then there is a Meta model as well. Then so these models are available. Then if you look into Tune model, as you will actually tune the model for your use cases, the model will be tuned and it will show up here. So now if you look into advanced, now here you can control the temperature. I talked about the temperature. What is the temperature? It's a trade-off. It manages the trade-off between creativity and hallucination. If you make model very creative, it will hallucinate more as well. And then let's keep the temperature at default. And if I write it, so now you can say, okay, what's the big deal about it? I can do that in ChatGPT, just open a browser. The big deal about it is that it is part of Google ecosystem. It means that it is not working in isolation. So whatever is you are writing here, it is connected to the assets that are here. It means that the prompts you can put in that prompt library, you can manage the prompt, you can fine tune this model, and you can directly store this output in a bucket, and you can create a workflow where this output goes directly to an EC2 where it gets processed. All those possibilities are there. That means that your large language model is not used in isolation. It is part of a more complex architecture that is around you. That all of a sudden opens new possibilities that are there. So Gen AI is where you can do prompt design, where you can do you can play with that. You can also fine tune model as well. And now when you fine tune the model, it means that, as I mentioned a couple of times, that we don't have a capacity to train a new large language model. You don't have a capacity to change it, but we can fine tune it. What it means is that through prompt engineering, or through some explicit statements, you mention that now this is my needs. If I'm working for government, you specify that now it needs to follow these regulations. You mention that these are regulations, and you need to make sure that the ethics, bias, and the jargon, the language that is used, it is in each response coming from the large language model, it abides by that. So we fine tune, we test this, and then we use it. So that is basically essentially part of fine tuning the model. Now, if you talk about no code tools, they are no code. So no code tool means that if you do not want to write any code, this is a no code solution that I showed you. When I showed you this, it means that here you are not writing any code here. All I did was that I just used the prompt. And if you want to write a code, then you click here. Now you get code. Now the code is here. Now this is not a no code solution. This is you want to write the code here. But no code solution is that you want to create the solution without writing any code. Now, if you want to optimize the performance, use batch processing. Batch processing. It means that you submit, for example, if real-time inference is not needed, don't use it. So it means that you submit your unlabeled data as a batch at the end of the day, or towards the top of the hour, or end of the week, whatever granularity works for you. So you don't use real-time inference if it's not needed, and you can use asynchronous. It means that forget and leave and let it infer and come back, instead of creating a synchronous solutions where it is a blocking call. Then you do use connection pooling, especially if you are creating more than an endpoints. So this is what you do is that you create a pool of connections where connection is ready, but it's in a passive state. It becomes active, that is used. Then I talked about this, that the model that you select, it needs to be in line with your needs. And then the region comes into play. choose the deployment closest to your region. It will reduce the latency and will improve the performance. And if you want to monitor it, so look at the response time, look at the token use, look at the quality scores, look at the cost, look at the error rates, and look at the feedback coming from the users. So this is something that we need to keep an eye. And if the model degrades, all models are expected to degrade. They age. The realities on the ground, they change. So we need to monitor it at some time. We need to retrain it, or we need to move towards a newer solution that is expected to happen. So we also need to make sure that for certain verticals, healthcare, financial, government, other as well, ethics, bias, and safety, that is not that is baked into the solution. That is not an afterthought, but we think about it right in the beginning, and we are making a solution that conforms to the responsible AI frameworks. Bias is that systematic favorism, for example, towards a gender or towards a race, either mostly unintentional, but we need to be aware of that. For example, if you ask large language models, still the surgeons are male and the nurses are female. Now it's a bias, gender bias, that is built into those large language models because their training data sets have those patterns. Now the difference it will make is that as we are using these large language models towards sophisticated decision making, then those bias will make a difference. So we need to be aware of it, and we need to come up with the mitigation strategies as well. Now let's talk about the key takeaways. So here we started with this defining the and first of all, key terminology. We started with tokens. We talked about the importance of prompts. We also talked about using this large language model as part of our larger application. This is first thing that we did. Then we talked about what Google has to offer. We talked about different models that is there. Palm 2 was one of them. And we said that there's Model Garden where you can window shop up a large language model. Then there is Gen AI. Gen AI Studio. Now, Gen AI Studio is where you develop, and there's a no-code option there as well. I gave you a demo as well where you can write a prompt, and the output that comes out of it. This is part of the Google ecosystem. It can be consumed by other components within Google Cloud. Prompt engineering, I gave you example as well that without prompt engineering and with prompt engineering, the code that was generated about LangChain on Google Cloud, it's important to look at your vertical, look at your needs, look at what is needed, and whatever you do, you choose an option that is responsible and free from bias and is safe and is explainable and transparent. Now, that's all I have for today, but thanks for your attention and any questions that you have.
Thank you, Imran. That was incredibly insightful. Now, I know everyone's looking forward to the Q&A session, so go ahead and start putting your questions into the questions panel. And while you do that, I'd like to give the presentation rights over to Ifla, our product marketing person, who's going to introduce you to some of our fantastic promotions and webinar-related courses.
Thank you, Tracy. Insightful session. I believe everyone must have learned something new today or would have been able to brush up their skills around Google Cloud technology.
So, firstly, I'm excited to announce that Netcom Learning is now an authorized training partner for Google Cloud, making us your go-to destination for cloud skilling. With this milestone, we are proud to offer comprehensive training across the three leading cloud technologies globally: Microsoft Azure, AWS Cloud, and now Google Cloud. So, Netcom Learning, is your one-stop shop for cloud skilling. I would also quickly like to take you through some of our hand picked resources, which we think will immensely help in accelerating your Google Cloud skilling journey. Well, this document here that I'm presenting has been shared with you all in the handout section of GoToWebinar panel. You can download this document and access all the resources and browse all the offerings we have curated for you. So first up is the list of our recommended courses, which we feel will best suit your learning journey after attending our masterclass. So all these courses here are hyperlinked. Feel free to go through them post event and check out the course descriptions and prerequisites and the value it can add to you and your team skill sets. Additionally, we have curated a blend of resources, including our upcoming and on demand events, as well as some informative and educational blogs. So you can make the most of these resources to gain extensive knowledge on the Google Cloud topics they cover. Also, here I would like to inform you that today's masterclass session is being recorded. So, in case you want to refer back to any of the topics that were covered by the trainer today, we'll be sharing the recording link with you through emails, and also you can access the link here on the handout so that you can revisit the session and learn at your own pace. Now, apart from our virtual sessions, you can also catch all the relevant updates related to IT and business training on our social media handles. So please feel free to follow us on LinkedIn, Twitter, and Instagram, and also subscribe to our YouTube channel for all the latest updates. Our official pages and channels are linked here on the icons. Finally, if you have any suggestions regarding the topics you would like us to cover in our upcoming webinars and masterclasses, please don't hesitate to send us a direct message or leave a comment on our social media posts, or you can just simply email us at google@netcomlearning.com. We would definitely try to come up with the sessions on your suggested topics. Thank you once again for joining us today. You guys have a good one. Thank you.
Thanks so much for guiding us through that information, Ifla. And now we're going to go ahead and jump right into our question and answer session. How do I decide between using PALM2 and Gemini for my application?
Okay, we talked about this, but let's explain it more. So Palm 2 is simpler than Gemini. It's for if you have question and answers, if you want that conversational experience, where just like you are interacting with a chatbot, or you're doing a conversation on a WhatsApp, the same thing. If you want to the same behavior you expect from a Gen AI solution, then Palm is a better option. Right? Gemini is a foundational model. It's a multi-model. It can understand audio. It can understand images. It can understand text. It can mesh this all up, pick up the signal, and generate the solution for you. But for some use cases, like these conversational ones, it is an overkill. It can be used, but it will be most costly. So don't use Gemini unless you need it.
Can you give an example of how a product team might use generative AI Studio without any coding?
Yeah, so for that, the first thing is that you go to Vertex AI, and from Vertex AI, you go to Gen AI Studio. And in Gen AI Studio, you will see different options there. So Gen AI is right here. So the first thing I would say is that you click here. Okay, you click here. It says create prompt, and create prompt gives you this screen where what you do is that you write the system instructions that what you want, for example, your company-wide policy, and the user prompt. User prompt is that now the system prompt is for one problem or one company, it doesn't change, and the admin has the privilege of changing it. And the user prompt is that what they do is that the specific questions that they have, they write it here. There is no code that need to be written, and the answers that is there, you can consume that just by reading it or storing it somewhere and making it part of a workflow. This is the best way, the most effective way of using Gen AI without writing even a single line of code.
What are the cost considerations when scaling an LLM-based app on Google Cloud?
Okay, so the cost consideration is it depends on your resources, that first of all, your non-functional requirements. So what is the performance that is needed? If your expected solution needs to respond within 5 seconds, I gave you the example that IKEA customer talking to IKEA about order, it cannot wait for more than 2-3 seconds for each response, or maybe 5 seconds. It cannot wait for 3 minutes, of course, you know. So it means that if your requirements, your performance requirements will come from your use case. What are the non-functional requirements? You know, what is the response time? The second thing is that do you want that response to be in real time? Real time inference is many times, 10 times more expensive than batch. If you can afford to wait towards the end of the day, you know, let's say that these are mortgage applications and the bank can afford to wait towards the end of the day, submit the sheet with all those unlabeled data, and the response comes at DC, and it will be 10 times cheaper. So it will come from what are the requirements, and based on that you should be choosing not always the latest and greatest, but more about reducing the cost as well, if you can.
How do I integrate an LLM with my existing app backend on Cloud Run or Firebase?
Yeah, so that's a good question, you know. So the best way is containerize that, you know. So because if you are talking about a Cloud Run is all containerized, you know. So instead, so what you do is that the solution that you create a container of that, and on the container level, it's very easy to integrate. So that will be just another container in the underlying Kubernetes cluster that you have, and it should be able to work very well with your existing architecture.
How do I ensure that the model responses are not biased or hallucinated in critical applications like healthcare?
Okay, so there is something that is called grounding. You know, grounding means that you want to make sure that so you grounding means that your model results, they should be realistic, and they should be matching what the reality exists on the ground, you know. So in the if the training data set, I talked about the doctors, the surgeons are male and nurses are female. Now it means that there is a bias there, gender bias there, you know. So first of all, there are two steps. First of all, you need to identify the biases, and the second thing is that you need to mitigate that, you know. And the best way of doing that is that you first of all identify that, and there are more than one strategies that you can bring in. First of all, maybe it doesn't matter in your use case, you know. You are not making a decision about the nurses and the doctors. You know, you are overthinking. This is about the mental health. This is not about hiring processes, so this bias is not applicable. But you want to make sure that for example, the prognosis of disease for different races are different, as we know, because our DNA is slightly different. Now in that case, the bias becomes important. You need to first of all flag that, and then you mitigate that by either grounding or combining it with a tool in that case, instead of depending on large language model.
Once again, I want to remind you that as you leave this session today, you will be presented with a short survey. We would like to request for you to help us by taking a quick moment to participate in that survey. Your feedback really helps us understand your learning experience, as we are constantly looking at how we can improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. We want to thank all of you for joining us today, and if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.